Hi everyone, and welcome to our video on algebraic limits and continuity. So in previous videos, we've been finding limits using graphing, or they've been given us a graph and we've been using technology, or we just use the picture. These are more doing it by hand without technology. But I mean, if you're allowed to, always use technology to double check. But this is the process to find limits. So the first thing we do when trying to find any limit, so here we've got our limit notation, the limit as x goes to a of f of x. First thing we try is to just do f of a, so just like evaluate a normal function. If that's defined, so which means it's some number, if it's a number, then we would be done. The answer would be that number. If it's an undefined, so if we get something like 0 over 0 or a constant over 0 or like an imaginary number, so like a square root with a negative in it, then we proceed with these 3 steps. Okay, so with rational functions, we try factoring. So rational just means you have a big fraction. For radicals, we might try multiplying by a conjugate. So we'll show that in the examples upcoming. And then if we have a complex fraction, we would multiply out the common denominator. Okay, so we'll see all of those in separate videos because they can be kind of long. There is some side notes here. When canceling out common factors, make sure they are identical. So like if you have x minus 2 divided by x minus 2, we could cancel those out. They would divide to make 1. But if it was x minus 2 over x plus 2, then this doesn't simplify and we can't do anything. Okay, so this does not simplify. And sometimes we can make them the same if there's minuses involved. So for instance, if we have x minus 2, we can change it to be negative 2 minus x in case we needed to get a match. So for instance, say there was a 2 minus x under that, then we could say, oh, these would now cancel, and I'd be left with negative 1. Okay, so kind of a lot going on with that little rule there. Okay, so it's just manipulating a negative. If it's piecewise functions, you might want to do graphs, and then still you can make a graph or table to double check. Okay, so let's just see these first 3. These ones are going to be kind of are this first case, but you'll see like number 4, we wouldn't know that. Okay, so let's jump into it. So the first thing we do, so they're saying this is f of x. We don't need to rewrite it like this, but I will for this problem. So it says 3x to the 5th minus 2x squared plus 6. And if I want to do this limit, the first thing I'm going to do is just see if when I plug in negative 1, if I get a number. So this is 3 times negative 1 to the 5th minus 2 times negative 1 squared plus 6. And then we could do our order of operations. We would have negative 1 to the 5th would stay negative 1. Or we could, even if you can use a calculator, you can plug it all in one big step. And then, oops, we don't need, let me rewrite it so we can do multiple steps in one here. Okay, so I'm doing these powers first. So the negative 1 to the 5th was the negative 1. Negative 1 squared will be positive 1. Negative 1 times negative 1 is positive 1, and then plus 6. And then we can see, oh, this is negative 3 minus 2 plus 6. It looks like it simplifies to be 1. So because this is a number, so it's not an undefined, that means this limit is 1. That's it. Okay, so sometimes it's just like evaluating a function. And like I said, you don't need to show rewriting the function like this. You can instantly plug it into these x's to see what would happen as well. So let's do that for number 2. So if I plug 4 in right away, I would have 4 squared over 4 plus 2. Notice when I'm plugging in that 4, I don't write the limit notation. So I just plug in the number and it's just the big fraction, no more limit notation. So because this is saying that we are doing it. And then from here we can see, well, 4 squared is 16. 4 plus 2 is 6. And then they would most likely want us to reduce this. These are each divisible by 2. So we would have 8 over 3. And again, if you can use a calculator, decimals can be fine as well. So that's it. That's a number. That means that is the final answer. Let's see what happens with number 3 here. Okay, so number 3, if I plug that 10 in right away, so I'm just plugging it into that x, I would have square root of 3 minus 10. Square root of this is negative 7. Okay, so, or the square root of negative 7. So here we have a negative in a square root. That means the whole expression is not defined in the real numbers. Okay, so that means it's an imaginary number. And in calculus, we don't care about imaginary numbers. So what this means here is that this limit, so let's write it official, the limit as x goes to 10 of the square root of 3 minus x does not exist. And we usually abbreviate that as D and E. Okay, so if we get something strange, so a negative in a square root instantly is a does not exist for these limits. Okay, number 4, we're not going to complete all the way, but let's see what happens if we do plug in 3. So if I plug in 3, I would have 3 squared plus 4 times 3 minus 21. And I would have 3 squared plus 2 times 3 minus 15. Now, if we do the order of operations, it would be 9 plus 12 minus 21. That will be 0. And then 9 plus 6 minus 15 is also 0. So this is a special case. This will be in our next video. Whenever we get 0 over 0, it means we need to use some algebra. Okay, so that means we need to simplify the original expression. Okay, so there we are. So I think I'll leave that up for the next video too. I think we could squeeze everything in right below still. Okay, but that's it for now. Okay, so these were some examples that you could just plug in right away. That's always the first step. Now, again, like in number 4 here, it didn't help us. It didn't give us a regular number. So that means we're going to have to do something after to see what it really is. Okay, so we'll save that. All right, that's it. Thanks for watching. If you have any questions, please let me know.